DeepMind CEO Demis Hassabis views Level 4 artificial intelligence as the arrival of Superagency. This is the point where AI moves past answering prompts and begins completing complex, multi-step goals without constant human oversight. This vision demands a shift in how we interact with technology. Instead of acting as operators who click through every step of a task, we become orchestrators who issue a single mandate and step back to let the machine handle the execution. Hassabis describes this new model as agentic payments. In this system, autonomous agents act as the primary transactors. You provide the budget and the goal, and the AI navigates the web to execute every necessary transaction on your behalf. However, by mid-2025, Hassabis pointed out a significant gap between this goal and our current capabilities. Even the most advanced coding agents today can't do things on their own and remain restricted to serving as assistants for human coders. If the underlying algorithms have reached such a high level of sophistication, why do they become so limited when tasked with managing the simple, interconnected chores of our daily lives? The bottleneck resides in the Internet's nervous system. The highly advanced intelligence of the AI brain is continually colliding with a rigid, fragmented infrastructure that was never built to support autonomous movement. The average enterprise relies on over 1,100 separate applications, a massive digital empire built on isolation. This is the connectivity gap. Only 29% of these applications are integrated. The vast majority of our tools exist as silos, cut off from the rest of the ecosystem. Every API speaks its own language, and every data model carries its own set of assumptions. This fragmentation ensures information cannot move freely without human translation. This lack of native communication creates a heavy tax on innovation. Developers spend 40% of their time building custom integrations just to keep disparate systems from falling out of sync. Because the software wasn't designed for cross-platform fluency, the current digital architecture is structurally incapable of supporting an AI that can act on its own. To see how this architectural failure stops an AI in its tracks, we can trace a single request through 3 common platforms. The AI begins by researching a health issue within a medical application. Within this one silo, the agent is highly effective and successfully compiles the necessary data. The failure occurs when the AI carries context to a budget application. The data packet shatters against a different API language, losing its connective tissue. Reaching for a calendar app, the fragmented data dissolves completely. The agent no longer understands the original goal. The human user is forced to step back in. Any time saved by the AI's research is negated by the need to manually rekey data and reconcile disparate spreadsheets to fix what the machines dropped. This proves that in a fragmented system, context physically disappears the moment it steps outside a single application, neutralizing the AI's potential for superagency. Achieving the Level 4 threshold depends entirely on addressing this deep infrastructural barrier. To realize the vision Hassabis outlined, the focus of the industry must shift. Creating more intelligent, isolated models will not bridge the gap if those models are unable to navigate the software we actually use. The new requirement is universal connective tissue. The industry must build a layer that allows every disparate application to speak a shared language, making context sharing a native feature rather than a manual chore. Until this layer exists, the consumer will remain an operator, trapped as a manual translator between machines that refuse to communicate with one another. As long as the Internet's infrastructure remains fragmented, AI will continue to lose its effectiveness at the boundary of every new application, keeping true superagency completely out of reach.